Let's focus here. Let's focus here and less on popular singers. Okay. Binary acids. We're going to start with all the non-organic acids. We're going to name them like the ionic compounds first, and then we're going to change that name to the name that we'd use for an acid. Okay? And that's all the acids we're going to name in here. When we have the name of the acid, then we're going to learn to write the formula by undoing that same process. Okay? Just like we learned to balance compounds, and then sometimes we had to learn how to unbalance those compounds or undo what we did in order to find the charge on an ion. Okay? We're going to learn to write the name by naming it like an ionic compound, then undo that process to write formulas. Okay? So we're going to start with binary acids. So let's start with this, HBr. So if we name this like an ionic compound first, this would be hydrogen bromide. Okay, hydrogen only has one positive oxidation number, so it's called just simply hydrogen. And so the bromine, which would have a negative charge if this were an ionic compound, has only a one negative charge, and any negatively charged atom we change the ending to IDE, so hydrogen bromide. Okay, this is what? Well, yeah, it's on that periodic table with the oxidation numbers I gave you. But it's also in that last column over here, or next to the last column over here, and you're the one that said all those are -1. Remember? Okay? All right. When we have a binary acid, for binary acids, and all binary acids, are you listening? We are going to remove the gin. Okay? High schoolers shouldn't have anything to do with gin, so we're going to remove it. Okay? We're going to change the IDE ending to IC because we don't want you getting sick with gin. Okay? Ick. And so the name of this then becomes hydrobromic acid. Okay?
One word?
Hydrobromic is one word. It all gets kind of joined together here. Hydrobromic. Okay? Got it? I'm telling you what to do with it. No, any binary acid. Anytime you have just two elements in the acid, you're going to do it this way. Anytime you...
Why did from the start you just make it hydro... Oh, you're just showing us...
I'm showing you how you learn to name it. Okay?
How are you going to binary acid?
Two elements. Binary means two.
Two elements without any, like,
Binary always means, when referring to formulas, binary always means only two elements. It doesn't mean only two atoms, only two elements. Now that has more than two atoms, but it only has two elements. Okay? So you name this now. All right, we've been spending a lot of time naming ionic compounds. Name it like an ionic compound, and then I'll come back and we'll together name it like an acid. Okay? Maybe you can go ahead and name it like an acid, but name it like an ionic compound first. There's no Roman numerals because the hydrogen is the cation, and the cation here, this hydrogen only has one oxidation number, so there's no reason for Roman numerals when you're naming acids. Does that make sense to you? Okay, if we're naming this like an ionic compound, The hydrogen only has one positive oxidation number, so it's simply called hydrogen. The sulfur, since it's a monoatomic anion, a single atom that has a negative charge, all we do is change its ending to IDE. So instead of sulfur, it becomes sulfide. To name the acid then, we get rid of the gen, we change the IDE to IC, we join it all together, and we get hydro sulfuric acid.
Why do you put the 2 in there? You just like
Put the what in there?
the 2.
The 2 isn't included in the ionic name. It isn't included in the acid name. Okay? When we're naming ionic compounds, we don't use prefixes. The prefixes are reserved for covalent compounds.
So we're naming acids?
Yes, we're naming acids. That's what it says right up here. Organic, non-organic acids.
Where you been?
I know, really. Okay. Alright. Well, y'all know I kind of get kind of spacey some days too. Everybody does. Okay. Alright. Let's try. Now look, guys. You really need to focus. Okay. You really need to focus your energy here on this. Because if your mind is somewhere else, you know that you're going to see that result on the test. Alright. We've been naming 4 categories so far. You got to keep up with what all those categories are and how to tell when you have one category or another. On the test, I'm not going to tell you this is an organic compound. You have to know it when you see it. Okay, and that's what we're going to practice after we finish acids. But if you've been paying attention closely up to now, you'll know it when we get there. Evan, did you have a question?
No.
Okay, let's try one more binary compound then, okay? Name it like an ionic compound, then change the name to be that of an acid. Alright. What's this called?
Oh, is that right?
What?
Hydride.
As an ionic compound, it's called okay, hydrogen iodide. To name it like an acid, we get rid of GEN, change IDE to IC. Yes, hydroiodic acid. Okay? Now this is how you name binary acids. Okay? Binary acids are the only acids that have the hydro prefix. Are you listening? Binary acids, only 2 elements, not 2 atoms, 2 elements, only 2 elements. Binary acids are the only ones that have the hydro prefix. We're going to go now to naming acids that have more than 2 elements now. Oxyacids. Acids that have oxygen in the formula. Okay? With all non-organic acids, oxyacids. We start the naming process by naming it as if it is an ionic compound. With all non-organic acids, we start the naming process by naming it as if it is an ionic compound. Okay? So we're going to start by naming this like an ionic compound. It has more than 2 elements. If it has more than 2 elements, where do we start? By naming it like an ionic compound. What's the rule when you have more than 2 elements? What is the rule for naming ionic compounds when you have more than 2 elements? What is the rule when you have more than 2 elements in a formula? Where do you look? Polyatomic ions list. Guys, you have to know this. Okay? Where do you look when you have more than 2 elements in the formula? Okay. So what polyatomic ion looks like some part of this formula? That's what we're trying to figure out. Well, we can actually just start with the sulfate ion over here. Okay, there is a hydrogen sulfate, you're right. Alright? But sulfate will work for this too. Okay? Let's name this as if it is a, well, see, when you said hydrogen sulfate, that's the name of a different kind of ion. Were you naming this hydrogen sulfate?
No, I was just looking at the trying to find it.
Okay. Hydrogen sulfate. Okay, SO4, 2 negative is sulfate. You put 2 hydrogens on there, you get that. That also happens to be the name of an ion, where you have just 1 hydrogen and the whole thing has a negative charge. It's also called bisulfate. Okay? But for this naming process, we're going to start here. Okay? Alright. Unlike binary acids, this is an oxyacid. It's a different set of rules, somewhat. Sulfate. Unlike the binary acids, we're not going to just drop the gen, we're going to drop the entire hydrogen off the name. And we're going to change ATE to IC. This then becomes sulfuric acid. When you have an oxyacid, so an oxyacid is going to have a polyatomic anion that includes oxygen. Sulfate includes oxygen, it's a polyatomic ion. We're going to name it like an ionic compound. Then to name the acid, you drop hydrogen off the front entirely and change 8 to ic. So binary acids you drop just the gen. Oxyacids, you drop the whole hydrogen. Okay? That's what's in a car battery, yes. Okay? So this is not sulfate. What is this? Sulfite. So we're going to name this hydrogen sulfite. Okay? We don't want to call this sulfuric acid. That's not the same thing. So when we have an ite ending, we're going to change it to something else. 8 endings get changed to ic. Ite endings get changed to OUS. And again, we drop the hydrogen from the front. Sulfurous acid. Okay, so name these acids.